everyone. First of all, very happy new year. And it is really exciting that the Procedural Fluid Simulator version 2.5 is released with many new features and updates. In this video, I'll demonstrate these new features as well as the new workflow. So let's get started. So you can get this preset from the Blender Market or from my Gumroad page. You will get these two zip files. One is the preset files and other is the project files. And with this release, I have provided all the project files that I have shown in the intro, so you can study them. So when you extract this zip file, you will get these preset files and the documentation. So you have to assign one of this folder as a library in the Blender preference according to the Blender version. Okay. And this is the documentation, and I have rewritten this based on this new UI of the nodes and also these new features and the nodes that I have added. In this, I have added a new section that is really important. That is the comparison study of parameters. Okay, let me show you that. So this one. So here I compare different parameters like solvers, their integration schemes, pressure iterations, trace steps. Okay, so this study will really help you to understand the settings, how it is affecting the overall simulation. Okay, so I highly recommend you please read this documentation. So now let us add this as an SL library. So I'm using Blender 5. So then go to the preference, and in the file path here we need to add that as a library. I'm going to add this file Fluid Simulator Blender 5 and add that as a library. Okay, in the import method I'll change that to append, but you can also keep that a pack. Only thing is that when you add that as modifier you have to unpack that. Okay, so that's why I prefer this append option. Let's save that. So now if you go to your asset browser, so there is a new category KS tools and it contains this fluid simulator. Okay, so it has subcategories like Advector, fluid simulator for curve, grid, mesh. Then you have the forces and the utility nodes. So first I'll show you how to add this to the object. In this release you have two options. You can use this as a modifier or you can use this as a node in the geometry nodes. Okay, so now I'll show you how to add this as a modifier. So let me first add a object, this plane object, and first we're going to add the grid. Okay, fluid simulator for grid. So let's drag this to this. So if we go to the material preview, we have this. See, this modifier bring this curve object and also this collision object. Okay, and next we're going to add this for the circle, curve circle, and let me increase it is resolution. And then we can add this fluid simulator for curve modifier to this. See, and let me move this collision object near to this circle so that we can see the simulation. See, and the last one is, suppose we have this mesh object and I'm going to add this icosphere, and let's also increase it is resolution, maybe 6, and let's move that here. And then we can add this fluid simulator for mesh to this. See, and let me move the collision object here. So now we have this. See, and this fluid simulator for mesh is not limited to this a sphere. You can use any object. Let's use this monkey, and let me add a 2 level of subdivision to this, and we can add this modifier to this. See, we have this, and let's bring their collision object here. See, we have this fluid simulation onto this monkey. Okay, so this is how you can add this as a modifier. And next I'll show you the new features and settings of these solver nodes and also the new utility nodes. Okay, so let's open a new file. I'm going to use the fluid simulator for grid to demonstrate the features, but all these features are available for all the solvers. Okay, so this is the fluid simulator for grid modifier. Okay, so it has this structure. You have the solver node and this is the fall off node, and if we Around this, we have this simulation. Okay. So in the solver node, you have two type of setting. One is the input setting, like in this case grid, and then you have these settings. So these settings are available for all the solver nodes, and there are some additional settings for the fluid simulator for mesh. So I'll also explain those. So now let's talk about this input settings, the grid. So in the grid settings, you can define different parameters of grid, like first one is the resolution. Okay, so with this you can control the resolution of this grid. Then you have the length of the grid, and you have the width of the grid. Okay, and there is a new setting that is the transform. So this allow you to transform the grid. Okay, so you can set the initial transform for the grid, like we can rotate this along the x-axis, and let me also rotate this curve. So we have this. So now this grid is no longer to confine to XY plane. So you can rotate this according to your need. So this is really handy. And next is the UV map setting. So you have two options for the size of the UV map. You can use the square, that is 1 by 1 UV map, or you can use the rectangle option. So that will use the length and width of this grid to set the size of the UV map. Okay. And if we go for the fluid simulator for curve, let me add that node here. So it has these curve settings. So let me quickly add the curve circle, and let's increase the resolution so that we don't have these artifacts. 120 times 2. Okay, so we have this. So first you need to input the curve, and then you can define its resolution using this step option, and this is the radius of this grid. And then you have the settings for the UV map. Again, you have the square option or this rectangle option. So it is going to use the length of the curve, and it's going to use this radius as width for the UV map. And after that, you have the profile. It has two options, the default profile and custom profile. Okay, in the default profile you can add that a line, or you can add that a circle. Okay, something like that. And you can also offset this along the x-axis and the y-axis. So these are the local transforms, and you can also change the angle. Okay, so this is really handy, like if you want to simulate kind of glass here, let me bring that. Okay, something like that. So these are the input settings for the fluid simulator for curve. And then we have the fluid simulator for mesh, and here you have only need to input the mesh object. Okay, so now let's talk about the initialization settings. Let me go to the top mode. In the initialization, you have the simulation, solver, advection, and boundary condition settings. Okay, so let's go to the simulation. Here you can define the start and end frame of the simulation. If I set this to 1 to 50 frames, then the simulation will stop after the 50th frame. And then you have this time step. So this is really important settings for this fluid solver. So here you have two options to set the time step. You can use the delta time. So that time is provided by the simulation nodes, or you can say this time is set by your scene based on this frame rate. And then you have the custom time step option. So you can also set the time step independent of your scene. Okay. And nice about this option is that you can also animate this if you want to slow down or speed up the simulation. And on top of this, you have the adaptive method. So you have adaptive time, adaptive step. So adaptive time will change the time based on this CFL number. So it's like a maximum velocity per cell. So if the fluid element is moving faster than this velocity, then it will change the time accordingly. Okay, so that the fluid remain stable. And if you change that to step, so this will not change the time, but it will do additional number of integration steps so that it meet the accuracy that is defined by the CFL number. So in this case, the CFL number act as a number of cells accuracy. Like if I set this to 2 and let me go to the wireframe, if the fluid element is moving faster than the 2 cells, then it will do the additional integration steps. So nice about this option is that it will not limit the speed. Okay, and for more information you can also check out the documentation. And then you have the solver settings. So here you can select the solver. So you have two options, fast and exact. Fast is based on the simple method and it is really good for the water simulation. Okay. And the exact is based on the actual fluid physics and it solves the fluid equations to do the simulation. So let me show you the fast, and if we run this, we have something like this. And let me increase the number of trace steps that I'll explain in a moment. See, now you have a really water-like effect. It's like some dye inside the water. So this is the exact solver. And for the exact solver, you have also this option, that is the pressure iterations. Higher the number of pressure iterations will preserve the vortices as well as the volume. So if I set this to 2, see, we have this really diffuse type of fluid. And if I set this to 50, then we have really nice fluid with vortices. So you can play with this option. And there is additional setting for the fluid simulator for mesh. So that is the this mode for the pressure calculation. So you have fast and exact mode, and most of the time you only need the fast mode for the pressure calculation. There are rare occasion you need the exact mode, and that is really computational heavy. So these are the solver settings, and after that you have the advection settings. In the advection you have a lot of option for the advections. In the previous version you can only advect the velocity, color and vector. Now you can advect the density, temperature and UV map. So now let's see the settings for the velocity. And first setting is the integration schemes. So you can select different methods for the integration. From semi-Lagrange to RK4, then you have macro-mac and BFECC. Okay, so these are really advanced methods and they are available for all these fields. Okay, and you can set them individually. So if we go from semi-Lagrange to RK4, we are increasing the accuracy, but all these methods are single step. If we select this macro-mac and BFECC method, these are multi-step methods and they really preserve the details. Let me show you this. So we have this kind of motion. Let me bake that. And now if I change that to macro-mac and rerun the simulation, let me go to this frame. Yeah, here. See, we have this, and this is with semi-Lagrange, and this is with macro-mac. And this will be more clear if I set this for the color. So we have semi-Lagrange, and let me go to the first frame and rerun the simulation. Let's say something like that. Let's bake this frame and then duplicate this and change that to macro-mac, and let's rerun this. So this is the macro-mac and this is the semi-Lagrange. See the difference. Okay. And after that you have the trace steps. So this is similar to the adaptive step. So this allows you to do additional integration steps and it will increase the accuracy of the simulation. And then you can also define the initial velocity for the fluid. So these are the settings for the velocity, and the similar settings are available for the density, temperature and all these fields. Okay. You can set the integration scheme and you can initialize them. In the UV map, especially for the grid and the curve, you don't need to initialize the UV map because that is generated by the grid. However, for the fluid simulator for mesh, you have this option to initialize the UV map. Okay, so you can define your UV map, which UV map you want to advect. Okay, so these are the advection settings. Next is the boundary settings. So I have reworked the boundary settings for all these solvers. So now they are clean and really easy to set up. So in this case, we are using the solid boundary. So the fluid will collide with this boundary of this grid. And you can also turn off this like along the x-axis, basically left and right. Now the fluid can cross this boundary. Okay. You can also make this open. So it will be open from all these boundaries. See, or you can change that to wrap. So it will wrap the fluid across these boundaries. And there is new option, that is selection based boundary. So first is the static selection. So let's add that. And next we have to define the selection. Okay, let me go to the first frame and let me duplicate this fall off node, change that to geometry, and let me add a curve here, curve circle, something like that. And let's bring that here, add that to this, Let's disable this option because we are using the curve, and let's slightly increase this, maybe 0.02 and this 0. Okay, so we have this and we can plug that to the selection. So now the fluid will collide with this selection base boundary. See, it is not crossing this. You can also select the dynamic selection. So basically you can change this selection during the simulation. Like we can move this curve here. See, now it is open, or we can move that back. So now you can play with the boundary. So this static and dynamic selection type boundary is available for the grid and the curve. Okay. And if I bring the fluid simulator for mesh, let me add that. So in this node, you have this boundary option. By default, this node automatically generates the boundary for the open mesh. Like in this case, it will generate the boundary for this grid on these open edges. And addition to that, you can also define the boundary based on the attribute. Okay. So these are the initialization settings. So now let's talk about the internal and external settings. So internal settings allow you to change the internal parameters of the solver like viscosity, vorticity, or etc. And in the external settings, you can input external data to the solver like density, temperature, forces, velocity, pressure, transform. Okay. In the internal settings, you have the dynamics, vorticity, and dissipation. So in the dynamics, you have the viscosity, sharpness, and diffusion for the velocity and pressure. Let's rerun this. So you can increase the viscosity to make this fluid more viscous. Keep this in mind that all these settings are field based. So you can input any field based map to this. We can, let's say, use the noise texture to affect the viscosity. Let me add the color ramp here, and then let's view this. Maybe 2 here, and let's slightly lower this, something like that. So the black region is there is no viscosity, and where there is gray region we have some viscosity. Okay, so rerun this. See, we have this kind of effect. You can also use the fluid parameters, like we have this node that is ks fluid info node. So this node provide all the attributes for the fluid simulation. Okay, also this memory attributes, and then the attributes for the particles that you want to advect, and also for the curve. Okay, so in this case you can use these fluid attributes to affect these inputs. Okay, so you can use the velocity to affect this. Let me add the length. So we have this kind of velocity. So if I plug this, so we have this kind of effect. Or you can use the color to affect the viscosity. Okay, so this is really handy, and this is really nice. For the color, you can even separate this. So you can use different color to affect the velocity. You can increase viscosity for, let's say, red color, and there is no viscosity for green color fluid. Okay, so you can do that. And then you have the new option, that is the sharpness. Basically, if you increase this, so you can increase the more vortex and more details to this. See, we have this. And if you decrease this, let's say maybe 0.75, so then it will really make the fluid diffuse. See, it is really smooth and diffuse. And then you have the diffusion settings for the velocity and pressure. So they are really important settings if you have some instability in the fluid simulation. So you can slightly add the diffusion to the velocity and the pressure. Okay, so this is really handy if you use the fluid simulator for the curve or for the mesh, because mesh or curve can have a sharp corners. So you may get some instabilities. So to suppress that, you can add the diffusion for the velocity and the pressure. Okay, so these are the dynamic settings, and then you have the vorticity. So this setting allow you to add the additional vorticity or additional force based on the vorticity to the fluid motion. It also allow you to overcome the numerical dissipations. Okay, if I set this to, let's say, 5, you will see we have more vortices in the simulation. Again, you can also affect these strength and this diffusion coefficient with the fields. And then you have the dissipation settings. So previously it is only available for the color. Now you have for the density, temperature and vector. So this allow you to fade the color, density or temperature. If I increase this to let's say 0.2, it's going to fade the color, maybe 0.05, something like that. And here you can define the fade color. So by default it's set to black, but you can use any color, okay, or you can even use the color map for this. So these settings are really important when you want to do the smoke simulation. So you want to decrease the temperature with time and density, so you can utilize these settings. So these are the internal settings. Now let's talk about the external settings. So as I have mentioned that, so these settings allow you to input external data to the fluid solver, like density, temperature, color, forces, and also the velocity, pressure, and transform. Okay, now we will come to this. Let's talk about the settings for the color. Because all these settings are similar for all these inputs, also for the density and also for this forces and the this velocity and pressure. Okay, so if you understand the settings for one of this, then the settings for other will be clear. So first you can enable or disable this external input, like we can enable or disable that, and then you can define the selection, so where you want to update this color. So like we can add that here, so we can use the selection to update the color. Okay, and for the color you have also different modes like mix, color, hue or saturation, and then you have this factor. So this factor allow you to gradually mix this color with the existing color of the grid, so you can also input that here. See, and similarly you can also set the density. You can add the factor or you can add the selection here, and then here you can define the density value. Same goes for the temperature, for the this custom force, and also for the velocity and pressure. Okay, and for the color there is also a dedicated node, so let me add that. So that is the color from collider. So this node allows you to get the color directly from the collider. Let me select the collision object and you can directly plug that here. Okay, so you can directly add the color from this node, and here you can define the fall off for this. And it has another feature, that is the color attribute. So you can use the attribute of the collision object to add the color. So in this way you can add a different color from different object. So that is really handy. You can also do that with this node, but you have to create that setup. Okay, and similar to this, there is also a node to add the velocity from the collider. So you can add that here, like you can directly plug this and here you can select the collision collection. So now let's talk about the forces. In the forces, now you have two options. One is the buoyant force and another one is the custom force. So the buoyant force is really important if you want to do the smoke simulation. Okay, so let me first enable this, and then you can define the selection. By default, it is true for whole grid. Then you can define the buoyancy strength, basically the upward force strength, and also the field. So in this case, we have color. We can use the color here, and let me make the sink strength 0. And here you can define the sink field, and then you can define the direction. If we run this, so we have this kind of effect. And here is also option to define your own custom field. Okay, so you can also define that. So let me change that to color here. And in the direction, because this is a field base, you can even use a noise texture, create a really random direction. So we have something like that. So with this, you can create really complex patterns with the fluid motion. Okay. And after that, you have the custom force. Again, you can define the selection where you want this force and also this vector. And here you need to input the force. And for this, you have these dedicated forces nodes. So let's add the turbulence. We can plug that into this. And if we run this, so we have something like this. And in this update, I have added this weight option for all the forces. So this allows you to weight this force based on different attributes of the fluid. Okay. So let's add the color value in this case. And we only want to add this force where this color is non-zero. Maybe 5 here. And it will be more clear if I disable the collision. So there is no motion. See, there is no motion, but with this force we have something like this. Maybe 20. Let's go crazy with this. And suppose you want to add different forces. Let me add another one, curve force. Okay, so we have this. If you want to add them, we'll just add the add vector node and add them together. Now you have these two forces. Now let me add a circle and let's bring that here and plug this into this node. Okay, change that to relative. So now we have this force. See, it is pushing along the normal of this curve. You can also make this along the tangent direction. It is really strong, maybe 0.5 and also make this 0.5. Okay, and you can even mix these forces, something like that, and here you can define the mix factor. Okay, so this is really powerful to create a really complex pattern with these forces. Okay. So next you have the advanced settings. So in the advanced, you have the velocity, pressure and transform. So why they are in the advanced? Velocity and pressure are the main attributes that are being solved to get this fluid simulation. So you need to be careful when you want to reset or modify them. And let's talk about this pressure setting. So that is new in this release. So this option allow you to easily create the source or sink regions on this grid. Okay, let me duplicate this node, change that to geometry, and let me add this sphere. Let's bring that here and plug that into this. So we have something like this, maybe something like that. We can plug that to the factor and enable this option. And let's say we want to set a positive pressure region near to this sphere. So what will happen? It will push the fluid away from this sphere. It's like a source. Okay, it is pushing the fluid away from this. And if I make this a negative pressure region near to this sphere, so it will create a sink region near to this sphere. See, we have this really nice spiral. You can even make it stronger, maybe -3. So this is how you can utilize this option. Okay, let me delete that. And the next is the transform. This is also new settings and a lot of user requested this. So this setting allow you to transform the geometry while simulating. Nice about this is that it also allow you to add the inertia from that movement to the fluid motion. So if I add the transform node here, combine transform node, and now if I move the grid, you will see it going to affect the fluid motion. And let me also define the weight, and I'm only going to add the inertia where there is no color. See? So now it is moving in the same direction in which the transform is happening, but you can also make this negative. So it will move in the opposite direction of the movement. So if I run this and move this along the positive, see, fluid is moving in the negative direction. So this is really handy. Like there is some water in a vessel, and if you move that vessel and the water is pile up in the opposite direction of the movement. Okay, so you can create that kind of effect. And suppose you don't want any inertia for the fluid, you can set this to 0 and it will not affect the fluid motion. So the movement of this fluid is only based on this collision object. Okay. So here you can define the inertia weight, and then you have the time step for the inertia. So you can use the delta time. So again, this is the time step that is provided by your scene, or you can use the time step that is being used by the fluid solver. So these are the external settings. And after this, you have the collision settings. In the collision settings, I have cleaned up the UI. So now it is really easy to set up the collision. Just select the mode. Like in this case, we are using the collection and define the collection here. And you have this collision. You can also define this animated option individually for different objects. So by default, it is enabled for whole geometry. Okay. Now you have two options for the velocity. You have the velocity multiplier, and there is maximum limit for the velocity that you want to transfer from the collision object to the fluid. And then you have the modes, proximity base and mesh volume plus proximity. And one thing I would like to mention is that, so this collision is not limited to mesh. You can also use the curve object to define the collision. Okay. So let me bring this curve, something like that maybe. And let's bring that here and we can add that into this. And because this curve has no volume, so let me change that to proximity and increase this distance maybe a 0.1. So now we can move this curve. Okay. I think 0.1 is really large, maybe 0.01, and also increase this. So we have this. Okay, and even you can rotate this. So this is the collision option. And next you have a new panel that is the visual. So these are the visual settings. In the visual, except this memory settings, rest of the settings not going to affect the simulation. So they are mainly for the post-processing. The memory settings, you can create the memory-based mask that you can use here for the solver, or you can use that for the post-processing, like to create some kind of fill effects or mix different materials. Okay, so let me show you this. So let's create a memory mask for the velocity and enable this option. And then I'm going to add the fluid info node, and let me see this mask here. And let's also define the threshold for the velocity. And if we run this, see it is generating this black and white mask based on this threshold. If I increase this, so it will generate a different mask. It will take this much time or this much duration to change from black to white. Okay. And with this settings, you can basically smooth this mask. So this is really handy if you want to control different parameter of the solver, or you want to mix different materials with time, okay, based on their velocity. And this is also available for different attributes of the fluid like pressure, density, temperature, color, and vector. Okay. And another thing is that it also provides the frame information where this condition become true for the whole grid. So you can use this frame information to get a really custom mask. So this is the memory mask settings. Then you have the displace settings. So it allows you to displace the geometry based on different attributes of the fluid. So let's displace this based on the velocity of the fluid. See, so you can displace this. So you have something like this. So these settings are available for all these attributes. So in the velocity, because velocity is a vector, so you have two options, either direction or a magnitude. So you can displace this along the normal using this magnitude or in the direction of the velocity. So with this, you can control the strength, and then you have min or max options. Okay. So you have this option, and then you can define the mid level. And with this, you can basically smooth this. So this is available for all these attributes. Like we can displace this based on the color. Let me shift this mid level. So we have something like this. It is based on the color. You can also use the pressure. And for this displace, there is also a dedicated node that is available, and it has more options. Okay, so you can even displace this after the baking, something like that, and you can do the same process here. Let me change that to direction. And it has like a vorticity gradient, and it also has this geometry option. So you can displace this fluid geometry based on external geometry like I used in this case. And next is the smooth. This allows you to smooth the different attributes of the fluid solver. Let's smooth this color. So you can smooth that. And suppose you don't want to smooth that here, then you can utilize this smooth attribute node. So it will allow you to smooth this after the simulation. And then you have the material settings. So these are the new features and settings for the solver. Now I will show you the new utility nodes and the advector nodes. So here you have new node, that is the fluid marching. So let me add that here. And another thing I forgot to mention is that you can also add these nodes from the asset browser. Okay, you can also add that from here. Let me go to the utility node here, and we have this fluid marching node. You can also add that from here. So this node allow you to get the fluid geometry based on different fluid attributes. So like in this case, we are getting that from the color. Even you can use the velocity. So we have something like that. Let's change that to color. So we have something like this. Then you can define the threshold, and you can invert this selection. And here you can define the smoothness. So this node is really important if you want to get this geometry, especially for like a 2D effects or motion graphics. Okay. After that, there is another node that is really important, which is transform attribute. So now you have this node that allow you to transfer the attributes from the fluid geometry to the target geometry. So if I add this icosphere, so we can transfer that to this icosphere. Maybe 5, and also add the set shade smooth. So we have this, and let's say we want to transfer the color information from the fluid geometry to the target. And if I add the fluid info node, we can see that. See, we have this color information. If I increase this, see, and let me also add the transform geometry node here and decrease it is Z scale, something like that. Let me disable this option. So we have this. And another thing is that because we have transferred the attribute to this target geometry, we can use the rest of the nodes. Like we can use this fluid displace node here, and we can displace this geometry based on this color. See, now we have this motion onto this icosphere. And if I add the set material node and select the material, that is the fluid material. So now we have this color onto this object. So this is a really important node to transfer the attributes from the fluid geometry to the target geometry. Okay. So these are the main new utility nodes. Now let's talk about the advectors. So for the advector, I'm going to first bake the simulation. So now our simulation is baked. So first we're going to add the particle advector. So you can add that from the asset browser. So this one, or you can add that from here. Okay. So let's add this from this. So we have this. To see the particles, first we have to enable them. See, we have these particles. And if we go to the first frame and run this, see, it is advecting these particles with the fluid motion. You can also hide the fluid geometry. Now we have only the particles. Then you have few options. First is the mode, emission mode. So you can advect the fixed number of particles, or you can continuously add new particles for the advection. Let me make this around 20. See, on every frame we are adding a bunch of new particles. Okay. Then you can define the life of these particles. You can even randomize this. And addition to this, you can also add your own custom points or particles. So this is really handy if you want to scatter some particles on a certain location. So you can do that. So let me change that to fixed and also make this 500. And then you have the initialization settings. So these settings are basically similar to the settings that are available for the solver. Okay. So in the simulation, you can define the start or end frame, and then you can select the time step here. And here you can initialize the color, or you can get the color from the fluid. If I go to the first frame, so we have this black color because our grid is black. And after this, you have the internal settings. So first is the projection. You can project these particles onto the fluid geometry, and with this offset, you can offset them from the surface. Okay, and here you can change the size of these particles, or you can get the size from the fluid. Like we can get the size of these particles based on the color. So if we run this, see we have these particles where the color is non-zero. Okay, and because it is field based, you can even use a different map like a noise texture to define the size of these particles. Then you have the dynamic settings. So here you can define the damp factor. So with this, you can basically damp their motion, something like that. Then you have the surface force, and it is mainly important when you have the surface moment in the fluid geometry. Okay. So these are the internal settings. After that, you have the external settings. The first is the color. So you can basically define the color based on the selection or the factor, or you can add the color from the fluid. See, we are adding the color to these particles from the fluid. And after that, you have the force. You can add the external forces to this. You can even utilize these nodes that are available here to affect the motion of these particles. And after that, you have the collision, and let me increase the number of particles, something like that. In the collision, you have two options. One is the self collision and another is the surface collision. So if you enable this, then particle going to collide with themselves. See, we have something like that. Let me slightly decrease this, make 2000. See, they are colliding with themselves. So here you can define the strength for the self collision and then the distance, or you can use the particle size. This is the number of iteration. And after that, you have the collision with the surface. So let me enable that, and let me select this collection that contain this object, our collider. So if we run this, see now this sphere is colliding with these particles. And here you can define the distance from this surface. So this is the collision settings, and after that you have the visual settings. Okay, in the visual you have the settings for the instance and the material. In the instance, you can like disable this. You don't want to instance anything on these points, or you can instance icosphere, cubes, or you can even instance lines. Okay, you have something like this. You can also instance on the custom object here. Okay, let me change that back to icosphere. So then you have the transform settings. So you can align their rotation along the velocity, okay, along the surface normal or the custom rotation. And this is for the size of these particles. You can use the size of these particles as the scale for the instance, or you can set your own scale for these instances. Okay, so these are the instance settings. After that, you have the material settings. So here you can change their shade and add the material. So these are the settings for this new particle advector. Another thing is that these advector nodes are not limited to this grid modifier. You can also use this for the fluid simulator for curve or fluid simulator for mesh. Okay. And next we're going to add the curve advector. So this advector also have the settings similar to the particle advector. Only few of the settings are different, like the input settings and the visual settings. So in the input settings, first we need to enable the curve. Okay. And if we go to the first frame and run this, then it's going to generate these curves from the points. Okay, let me go to the visual and delete these long edges. So you have this, and we can also hide the fluid geometry. So here you have three options. The first is to generate these curves from the points and advect them. So here you can define the number of points. Okay, so you have something like this. Okay, and then you have the instance curve. So basically you can instance different curves on this grid and advect them with the fluid. So also in the internal setting, let me slightly decrease this resample so that we have detailed curves. See, we have this. And in the input settings, basically scatter the fixed number of these curves and advect them, or you can continuously add new curves. Okay, let me decrease this. Okay, so you have something like this, maybe like that. So with this you can create really nice visuals. Let me change that to fixed. And for the distribution you have two options. You can randomly scatter them, or you can use the Poisson disk. And in the instance, let me change that to curve circles, so that will be easy for us to see this. And let me also decrease the scale, maybe 0.15, and let me close this. And now here we can define this minimum distance 0.3, and let's increase this. So now we can advect these curve circles with the fluid. See, in the instance you have also option to instance your own custom curve. Okay, so you can define that here. So here you can define the rotation of these instance and also their scale. Okay, and the last option is the custom curve, and this option is allow you to add your own custom curve and advect them. So if we add the curve circle, so we can advect that maybe 0.75. See, we are advecting this. And here you have also option to define the emission mode. You can basically add the fixed number of curve, or you can continuously add your own custom curve. So we have something less. We can even decrease its radius. Okay, so let me go to the first frame. So we have this radius, and then we can decrease this, and we can even disconnect that. So in this way you can create really amazing patterns with this. Okay, so let me delete this and change that back to points. So we have these curve, and let me also increase this to maybe 250. So these are the input settings, and after that you have the initialization settings. So similar to the particle advector, you can define the start or end frame and also the timestamp. And here you can define the color for these curves. So let me add the fluid info node and go to the curve. We can see their color, or we can get the color from the fluid. See, we have this. After this you have the internal settings, so you can project these curves onto the fluid geometry. Okay, and define their offset. And then you have the settings for the curve. You can set its radius. Again, this is a field base. You can input any field map to define the radius, or you can use the fluid attribute to define this radius for the curve. And let me add the profile here. Now these curves have the radius based on the color of the fluid. And if we change this mode, initial mode, let's say to instance or custom curve, then you have additional setting, that is the resample. So here you can define the resample length for the curves. It's going to resample the curve during the advection and create really smooth curve. So that is really important setting. So after that you have the dynamic settings. You can basically damp the motion of these curve and also add the surface force if there is a surface movement in the fluid geometry. Okay, and then you have the external settings. You have the color settings. You can set the color of these curves using these settings, or you can get the color from the fluid. Okay, and here you can add the external forces that are available here. Okay, or you can define your own custom forces and add them here. And in the collision you have only the surface collision. If I enable that and select the collision object, then these curves going to collide with this sphere. See, and here you can define the distance from the surface. In the visual you have two settings. One is the geometry and the material. So in the geometry, the first option is delete. So this will allow you to delete the long segments of these curves based on this threshold. And then you have the smooth settings, so you can smooth these curves using the fillet option, see, and also the blur option. And after that you can set their normals, like a minimum twist, z up, or the surface normal. The surface normal is going to set the normal based on this fluid geometry. Okay, then you can trim these curves based on the length. After that you have the profile option, so you can add the profile to these curves. So you have the line option, you can add the circles, or you can add your own custom curve for the profile. Okay, and then you have the material, and here you can add the material for the curves. Okay, so these are the settings for the fluid curve advector, and the last node is the fluid tracer. Okay, so let's add that here. And in the curve I'm going to enable this option, and if we run this, so we have these curves. And let me also hide the fluid geometry and decrease the number of points. Yes, something like that. So basically this node going to trace the fluid motion, the velocity of the fluid, or the velocity gradient of the fluid with the curves. Okay, so these are the input settings. Here you can define the number of points. In the initialization, you have the trace iteration and the color. So in the trace iteration, you can increase this, let's say maybe to 50, and we can also decrease this trace step. So if you decrease the trace step, it's going to more accurately trace the fluid motion. Okay, then you can initialize its color. Okay, or you can get the color from the fluid. See, we have this color. In the internal, you have the projection settings, you have the curve settings. Here you can set the radius of these curves, or you can set that from the fluid attributes. In the dynamics, you have the option to trace the velocity or the velocity gradient. Okay. In the external settings, you have option to set the color of these fluids based on this selection, or you can get that from the fluid. Okay. And after that you have the visual settings, so they are the same as we have for the curve advector. Okay, so these are the new advector nodes. So these are the new updates for the procedural fluid simulator version 2.5. So I hope you like this update. You can get this preset from the Blender market or from a Gumroad page. So get this preset and create amazing artwork with this. So if you have any confusion or doubt, you can ask me in the comment section, or you can ask me on my Discord channel. So thank you for watching. See you in the next video. Happy noding. Bye.